Have you ever looked up at the night sky and felt a sense of wonder? The universe is vast and mysterious. It's filled with billions of galaxies, each with billions of stars. But what if everything we see, everything we know, might not be real? What if our universe is actually a simulation? This might sound like science fiction, but it's a question that philosophers and scientists have been grappling with for years. The idea that we're living in a computer simulation, created by a more advanced civilization, is known as the simulation hypothesis. It's a mind-bending concept, but one that we need to consider as technology advances. Think about it. Our computer programs are becoming increasingly complex. We can now create virtual worlds that are almost indistinguishable from reality. It's not a stretch to imagine that a civilization far more advanced than ours could create a simulation so sophisticated that we wouldn't even know we were living in one. But if we are living in a simulation, what does that mean for us? What does it say about our place in the cosmos? These are questions that we'll explore as we delve deeper into the simulation hypothesis. The simulation argument was popularized by philosopher Nick Bostrom in his 2003 paper, Are We Living in a Computer Simulation? Bostrom doesn't outright claim that we are living in a simulation. Instead, he presents a compelling thought experiment. He argues that at least one of the following statements must be true. 1. Civilizations like ours go extinct before reaching a point where they can create realistic simulations. 2. Even if civilizations reach that point, they are unlikely to create simulations, perhaps due to ethical concerns or lack of interest. 3. We are almost certainly living in a simulation. Bostrom's argument hinges on the idea of substrate-independent minds. This means that consciousness isn't limited to biological brains. It could theoretically arise in any sufficiently complex system like a computer. If a civilization reaches a point where it can create simulated universes populated by conscious beings, it's highly likely that they would create many such simulations. This means that the number of simulated universes would vastly outnumber the one real universe. Statistically speaking, it becomes more likely that we are living in one of the many simulations rather than the original universe. Why would an advanced civilization create a universe simulation in the first place? The possibilities are intriguing. Perhaps they are conducting scientific research, running countless simulations to study the development of civilizations or the laws of physics. Imagine a giant cosmic laboratory where every variable can be tweaked and observed. By creating and studying simulations, they could gain insights into their own universe, or even explore alternate realities. Entertainment could be another motive. Imagine a civilization so advanced that they have exhausted all forms of entertainment in their own reality. A simulated universe filled with challenges, complexities, and endless possibilities could provide the ultimate form of escapism. Or maybe it's simply curiosity. Humans explore the world around them, driven by an innate desire to understand. An advanced civilization might be driven by the same curiosity on a cosmic scale. Creating a universe simulation would be the ultimate expression of that curiosity, a way to explore the fundamental nature of existence itself. Whatever their reasons, the possibility that we are living in a simulation created by another intelligence raises profound questions about our place in the grand scheme of things. Our universe operates on a set of fundamental laws of physics. These laws are remarkably consistent and can be expressed mathematically. This has led some physicists to speculate that these laws might be analogous to lines of code, the foundational rules governing a simulated reality. The elegance and precision of these laws, from the behavior of subatomic particles to the movement of galaxies, could be seen as evidence of a carefully crafted program. Just like a computer program relies on code to function, our universe might be running on a set of fundamental instructions that dictate its behavior. Furthermore, the concept of error-correcting codes, used in computer science to detect and correct errors in data transmission, finds an intriguing parallel in the laws of physics. Some physicists have proposed that the universe might have built-in mechanisms to correct for errors or deviations from its underlying code. This idea is still speculative, but it highlights the potential connection between the principles of computer science and the fundamental nature of our universe. If we are living in a simulation, could there be glitches in the matrix? While the idea might seem far-fetched, there are unexplained phenomena in the universe that could be interpreted as evidence of a simulated reality. For example, some physicists have pointed to the observer effect in quantum mechanics as a potential glitch. The observer effect suggests that the act of observing a quantum system can actually influence its behavior. This strange phenomenon, where consciousness seems to play a role in the outcome of physical events, could be a sign that our reality is not as straightforward as it seems. Other anomalies, like the presence of dark matter and dark energy, which make up a significant portion of the universe but remain shrouded in mystery, could also be seen as potential glitches. These unexplained phenomena suggest that our understanding of the universe is incomplete, and there might be underlying mechanisms at play that we are not yet aware of. While these anomalies don't definitively prove the simulation hypothesis, they do raise intriguing questions about the nature of our reality and the possibility that it might not be as it appears. Quantum mechanics, the branch of physics that governs the subatomic world, is full of mind-boggling concepts that challenge our intuitions about reality. One of the most bizarre aspects of quantum mechanics is the idea of superposition, where particles can exist in multiple states simultaneously until they are observed. This strange behavior, along with other quantum phenomena like entanglement, where two particles become linked and can influence each other instantaneously regardless of distance, has led some physicists to speculate about the nature of reality itself. Could these quantum weirdness be hints that our universe is not as solid and deterministic as we once believed? Furthermore, the fine-tuning of the universe, where the fundamental constants of nature seem to be perfectly calibrated for the emergence of life, could also be seen as evidence for a simulated reality. It's as if the universe's parameters were carefully chosen, like settings in a computer program, to create the conditions necessary for our existence. While these quantum clues don't provide definitive proof, they do suggest that there might be more to reality than meets the eye, and the simulation hypothesis offers a compelling framework for understanding these puzzling aspects of our universe. The simulation hypothesis, while intriguing, is not without its critics. Some argue that it's impossible to prove or disprove, making it more of a philosophical thought experiment than a scientific theory. Others contend that it's a form of technological solipsism, focusing on our own potential to create simulations while ignoring the possibility of other, perhaps more profound explanations for the universe's existence. While these counter-arguments are valid, they often delve into the realm of philosophy and metaphysics. They highlight the limitations of our current understanding and the difficulty of definitively proving or disproving such a grand concept. However, the lack of definitive proof doesn't negate the value of exploring these ideas. The simulation hypothesis, even if ultimately unprovable, forces us to confront fundamental questions about our place in the cosmos, the nature of reality, and the limits of our own perception. If we are living in a simulation, what does that mean for our free will? Are our choices predetermined by the simulation's code, or do we have genuine agency within this simulated reality? This question has profound implications for our understanding of morality, responsibility, and the meaning of life itself. If our actions are predetermined by a pre-written code, then the concept of free will might be an illusion. We might be nothing more than sophisticated puppets, acting out a pre-scripted drama. This deterministic view can be unsettling, as it challenges our deeply held beliefs about autonomy and accountability. However, it's also possible that the simulation allows for a degree of randomness or emergence. Perhaps the code sets the initial conditions, but the complex interactions within the simulation give rise to genuine unpredictability and free will. In this view, our choices would still have meaning and consequence, even within the confines of a simulated reality. Ultimately, the question of free will in a simulated universe remains a philosophical enigma, a puzzle that might never be fully solved but continues to fascinate and challenge our understanding of what it means to be human. The simulation hypothesis, whether true or not, serves as a powerful reminder of the vastness of the unknown. It compels us to look beyond our everyday experiences and contemplate the true nature of reality. It encourages us to ask big questions, to embrace curiosity, and to never stop exploring the mysteries of the cosmos. Perhaps one day we'll have the technology to create our own simulations, populated by conscious beings. This prospect raises ethical and philosophical dilemmas that we need to grapple with now. If we can create conscious life within a computer program, what responsibilities do we have to those simulated beings? The simulation hypothesis, at its core, is a story about perspective. It challenges us to step outside our anthropocentric viewpoint and consider the possibility that our reality might be just one of many, nested within a grander, more complex structure that we are only beginning to glimpse. It's a reminder that the universe is full of wonders, and the greatest discovery might be the realization that we are part of something far greater than we ever imagined.